Okay, suppose x and y are functions of t, so we're adding in a time for this. It says differentiate each side of the following equation with respect to t. Now notice there aren't any actual t's in here, but x and y are both functions of t. So maybe x equals 4t plus 6 or something like that. What this does is basically, it means that this is basically a chain rule for this problem, a chain rule for this problem. The x squared is the outside function, and then we're going to have to multiply the derivative of the x squared times the derivative of the inside function, and the inside function is your x with respect to t. Do the same thing for the y squared. So this is like implicit, where we took derivatives of y's with respect to x and needed a dy dx. Now we're going to need a dx dt and a dy dt. So the derivative of x squared is 2x. But its times are u prime, or the derivative of the inside, dx dt. We took the derivative with respect to t, and this is definitely not a t, and nor is this. So plus the derivative of y squared is 2y dy dt, and then the derivative of 4 is 0. So this is with respect to t. Now, what we're going to do when we do related rates problems is we started with some equation, x squared plus y squared equals 4, and they are related. X and y are related by this equation, and time is involved. The rates, dx dt and dy dt, are related by this equation, so they are related. Now, what can happen is you're given some information, and at a certain point, you can figure out the rest of the information. Now, this is all instantaneous rates, so you have to be given information at a certain time, and they don't necessarily have to give you that time, but everything has to be at the same time. So it says if dx dt equals -2, so I know my dx dt will be a -2. Find dy dt when x equals 1 and y equals -3. Now this is a constant because it didn't say at any given time. It says find dy dt when x equals 1 and y equals the square root of 3. So they have given us everything except for dy dt, and that's what they've asked us to solve for. So my equation would now be 2 times 1 times -2 plus 2 times the square root of 3 times dy dt equals 0. And this is fairly simple to solve. This right here is -4, so I'm going to add 4 to both sides. 2 square root of 3 dy dt equals 4. I'm going to divide by 2 square root of 3. So dy dt equals 4 divided by 2 square root of 3. And if I simplify a little bit, I have 2 over the square root of 3. So what I actually know that's going on says dx dt is -2. That means that if we're talking about some particle or something, it's moving to the left because x is left and right. So I know it's moving to the left at some rate of 2 something per something, but it's negative, so I know it's going left. My dy dt is positive, so I know that it's moving in the upward direction. So it's moving to the left and up, so it's going like that in this direction. And that is all happening when x equals 1 and y equals the square root of 3. So it tells me a lot about the motion of whatever this is. Okay, now a lot of these problems are going to deal with some geometry. So it says, given that the volume of a cone is v equals 1/3 pi r squared h, find dr dt, the rate of change of the radius with respect to time, when the radius is 2 inches, the height is 3 inches, the volume is 4 inches cubed, the rate of change of volume with respect to time is 1/2 inches cubed per second. Now notice the volume, dv dt, has an inches cubed, and it's a rate, so we've got the seconds. Also notice this is positive. That means that the volume is increasing, but it also gave us the rate for the dh dt. That's the rate of change of height with respect to time. So that is 3/4 inches. Height is measured in inches, volume in inches cubed. But the height is also increasing. So I want to say right now that does not mean that the radius is increasing. Just because these are, it could be getting very tall while at the same time it was getting skinny, and it could be getting taller faster than it's getting skinnier, and that would actually mean that the dv dt could be positive, but we're going to find out when we work the problem. So you start with the equation that relates all your variables. So v equals 1/3 pi r squared h. And we want the equation that relates all of our rates. So we need to take the derivative of this with respect to t. So the derivative of v, and notice there are no t's, so this would be 1 dv dt. Then what we have right here is the product rule. My first function, I'm going to keep the 1/3 pi with the r squared. This is just a coefficient. So it's 1/3 pi r squared, and my second function is just this h, the height. So it's the first function, 1/3 pi r squared, times the derivative of the second, and this is with respect to t, so dh dt, plus the second function, h, times the derivative of the first, bring the 2 down, so 2/3 pi r to the first, times the derivative of the second function, dh dt. And this is the equation that relates all of our rates. Now they gave us a whole lot of information, so we're supposed to be finding dr dt. I'm sorry, this is dr dt. Haha, I did it. It's right here. Be careful. So this was first function times derivative of the second, plus second function times derivative of the first. It's 2/3 pi r to the first, dr dt. Okay, so now we're ready to plug in. So I know that dv dt is 1/2 equals 1/3 pi, my r is 2. My dh dt was given as a 3/4, plus my h, which was given to me as a 3, times 2/3 times pi, times my r is 2, times dr dt, what I'm actually looking for. So you could do this with a calculator if you have one, or just simplify what you can. So I'm going to simplify a little bit and solve by hand. So this is a 1/2 equals, now if I look, my 3's are going to cancel out, and this is 2 squared, this is 4, those are going to cancel out as well. I'm left with a pi, plus my 3's are going to cancel out, my 2's get multiplied, so 4 pi times dr dt. So what I would do next is actually subtract pi and divide by 4 pi. So I would have a 1/2 minus pi equals 4 pi dr dt. Divide both sides by 4 pi. So I have a 1/2 minus pi divided by 4 pi equals dr dt. If you wanted to clean this up, you could multiply by a very clever form of 2. I'm sorry, a clever form of 1 in the form of 2/2, because 2's in the denominator. This cancels out, and I would have dr dt equals 1 minus 2 pi over 8 pi, and now I need units. So when they give you units, you have to use units, and what you want to think about is it's the rate of change of exactly what. In this case, it's a radius. Radius is measured in inches, so I'm going to do inches, but it is a rate of change, so I need per my time, which was measured in seconds. In this case, it actually came out to be negative 1 minus 2 pi is definitely negative. Divide by 8 pi, it stays negative. So our radius is actually shrinking. That is the first few examples. Those are the first few examples.